Okay, so for now, for the HSRP configuration, I have taken this portion of the topology. Okay, so that is let me just point it. So we were all were here. Now we just moved out from that and we took a new section. Okay, so let me tell you what is what here.
Sagar, I have a question for you.
Yes.
So let's see, if I enable HSRP on core layer,
Yes.
you said if priority is same.
Yes.
So you said highest IP address will take stand kind of what do you call it, active.
Okay.
So for my question is, if uplinks, let's say if it's going to connect you to internet, so the LAN connection. So let's say if the LAN connection IP address is higher, if it's the uplink to ISP, so how it works? I have a kind of confusion right now. So which one it will take? Which path it will take? So
for
so I'm connecting.
yeah, so from this network topology point of view, so let's say this is one router or gateway, Moscow R19, and I have Moscow R20. Okay, and if you say one of the link which connects to the ISP is down, so yeah, HSRP is going to track this interfaces, and basis on that the active to standby and standby to active will be triggered. So is that your question? Hello.
Sorry, my question is, you said highest IP address will take active role.
Okay.
So you enable on the LAN side, okay? If you enable on LAN side, so that highest IP address will take active, okay? That's core router will take active.
Okay.
So what happened to that? The uplinks. That means it's connecting to the WAN connections, the IP address. So how do you perform that scenario? So
are you referring to the case where we discussed that we can run two HSRP instances, one between the routers and one between the switches? Is that the question?
yeah, if I connect that,
Yeah. So now, okay. So now if you see the first HSRP instance, which is running between the switches, right? In this example, the purple, right? The Moscow example, the HSRP will.
let me tell me my question is okay. So
Okay.
the LAN connection, if I enable HSRP and if it post IS IP address, you said IS IP address will be active. So
Okay.
the LAN side, I'm talking about the LAN side.
Right. Okay.
So what happened about the the interface that is facing outside? That means to IS.
So now if you see the HSRP is running between switch 01 and switch 02 for the LAN side. Okay, the PC12, right? PC12, the default gateway is residing on the switch 1 or switch 2. Okay, now this will take it. So the WAN side, the HSRP is running between the router 19 and router 20, right? So now whatever the active election HSRP happens between router 19 and router 20. So your first hop, for the first hop redundancy from PC12, HSRP active will be chosen between switch 1 and switch 2 based on highest IP address or the priority. So now for the next hop between router 19 and router 20, the HSRP active will be chosen between these two based on, again, the priority or the IP address. Not on the interface of the, not on the gig 0x1 and 0x1 on switch 1 and switch 2.
Okay.
Does that help?
Yeah. Let's do, when we're doing a practical week, I can understand, I think.
Okay.
Okay.
So I want to have one more question. So is that your question, or are you saying that if this core router is connected to another ISP something?
No, my question is, if anything happened to the core router, so let's see if the active, you said that if the priority is same,
Okay.
so IS type will take, the active.
Okay.
So in that case, outside, the outside that core router is facing the ISP, it has more, the second one that standby has
Okay.
more IS IP.
Oh.
What happened? That is my question.
So see, okay, see, your active and your standby is on a complete box. Okay, so when this is active, so that active is for this as well as for this. Okay, so if,
Oh,
yeah,
I
if any traffic is coming to this, your switch is forwarding here and then it's forwarding here. Now for some reason HSRP detects this is down, that's enough for the change, the for the election to get reintroduced, and then this becomes active. So when once it is active, that is accountable for the LAN point and from the WAN point as well. So in this case it will be sent here, that will be sent to this, and then this router which is active will take care of.
Now it's clear. Okay,
Okay.
I got it. Thank you.
Yeah.
Now it's clear.
Okay. Okay, so let me first explain this scenario. So in this, these are the different users. So let's say I have VLAN 1 here and VLAN 1 put up here, then VLAN 40 and VLAN 40, and they are connected to this access point. So I don't need to access switches here because I'm not going to put any HSRP at this moment on this boxes. Okay, since they were already been created, I'm just using them. Okay, and in between them I am going to use a trunking port, and over here I'm again going to make use of a trunk. This is going to be a trunk, and over here, as you know, the concept of inter VLAN, what you call a stick on router, where I created sub interfaces. So the first sub interfaces will be encapsulating VLAN 1. The second sub interface will be encapsulating VLAN 20 data. So over here, we will see dot 0.0.1 and 0.0.40. Okay, so this is how this whole configuration is. So when once you go back to the workbook, you will be you can yourself practice it. Okay, I just demonstrated so that before telling you the initial conf, then might be I you will not understand what is HSRP. Okay, so this is a basic thing which I have done, and uh, from the PC point of view, first thing I'll show you is the normal behavior. That is, this is the IP address of this. Now, what is the gateway that I'm going to set? So I'm going to set a gateway on this VLANs. Okay, so I have written here. So this is my gateway for VLAN 1, and this is my gateway for VLAN 40. So VLAN 1 will have a gateway pointing to this. So on this computer, so let me show you what I'm trying to say. So I'll go to right click, I'll edit. This is a Linux based Docker, which is only available on GNS. Okay, so these are few things which you will not see on EVNG. So let me show you which kind of Docker I'm using. Might be EVNG Pro has this, but community version will not have. Okay, so these are Alpine Linux Docker, which will work as your VPCS instances. Okay, only the plus point about these are the IPs will be saved from one lab to next lab, whereas in your VPCS, that is these ones, they will lose their configuration every time. Okay, well, so let's come out of all that thing. So let's say I have configured IP address to this computer, class C IP address, and the gateway, I'm going to give the gateway of the first router, or the first, this one. Okay, so this computer user has a gateway of this to reach internet. Okay, I'll try to ping 8.8.8. So let's do that first. So let's power it on. And if you're wondering how I'm able to reach 8.8.1, that's because on a uplink side, I made use of a NAT adapter. Okay, I'm running a NAT adapter. That's nothing but from the available list. I just took one of the NAT adapter. Okay, I placed it on my topology and I just changed the icon. So you can get any number of icons from internet. So I just had one icon and I just placed it. Okay, just to make the topology look better. So nothing technical. Once again, it's all the default thing, and I just running this. Okay, so by default I must get one IP from the NAT adapter on my so one of the IP here will be from the NAT adapter. Okay, and then it's all your access port, trunk port, once again trunk port. Okay, and that's how we have it reachability to this. So all my goal is to send a ping packet to the gateway, and the gateway will take care of internet. Okay, so let's go to the console of computer 10. What is the IP of this? It's 172.16.10.10. Let's try to ping 8.8.8, and I have a reachability to internet. Okay, now let's keep this going. And let me also parallelly take the console of this router. And on a router, let's talk about this interface. What if this interface somehow is stopped? Now, as soon as this gets stopped, your packet which was moving in this direction will also get stopped, and all your reachability, that is your user 10 to internet, will be lost. Okay, so I'll show you by doing the interface shutdown. So let's do E0/1 and put it under shut. Okay, so if I do this, yes, I lost the internet reachabilities. Okay, very expected behavior. And now this is somewhere where I want to introduce HSRP. I will change the gateway of this computer. They will no longer be pointing to any physical interfaces. Instead, they will be pointing to a logical or a virtual IPs. Okay, once you have the virtual IPs created on a device, on a backend, they are going to create a virtual MAC address, that is a nothing but HSRP MAC address, and that is how your bindings happen. Every time if they detect some kind of outage, the switch which has a MAC address binded with both the switches will know whom to send in the case of outage, and that's how your redundancy will come into picture. So as of now, if you see this from a switch point of view, the MAC address association, you will see the MAC address. Let's say you will see one MAC address associated with this, another MAC address of this interface associated with this. Okay, and that's how your traffic is moving across. Now we will eliminate all this physical involvement. Okay, instead of physical, we will bring a logical or a virtual IP. Now this virtual IP is something which is configured under this interface, also under this interface, the same IPs. Okay, these IPs will create a HSRP MAC address which will be placed here. Okay, now the binding will be happening with this, not with the physical interfaces. I'll just show you how, as of now, before starting the HSRP. So let's see the MAC address. So from this point of view, very simple MAC address table. On 0/3 I have the computer 10. On 0/0 I have two MAC address. Okay, one is a MAC address from the switch, and might be one from some other device, might be the router or from the computer. Okay, and on the 0/1 I have this interface associated. So if I want to see the physical MAC address of that, so let's see, show IP int 0/1. Okay, so it's disabled, so I'll just bring it up. Okay, so if you see this is the MAC address, which is nothing but the MAC address of a physical interface of the router. Okay, so whatever MAC address is associated here, that's in the MAC address table of your switch. Okay, that is the binding happening without HSRP. Now we need to take that default behavior, and now the binding must happen on the MAC address that get generated when you run HSRP. Okay, so these are few things which you should know from the packet level, because configuring HSRP is very simple, but what is the back end of this? How is the packet flow associated? That's more important. Okay, so I'll enable debugs on this routers. Let's say I run debug standby events. Okay, and on the switch everything is set up like I have the access layers and the trunk layer. I just allowed 1 and 40, and on an access layer I have just added up the VLANs. Okay, it's on VLAN 1, so by default it's running up VLAN 1. If you see Giga Ethernet 0/2, I have the second VLAN 40. Now let's configure HSRP straight away. Okay, I will show you the interface that I have on the router. Okay, so looks like, okay, this is the router, right? Show IP int brief. So I have one interface or sub interface. This is a gateway for VLAN 1. This is a gateway for VLAN 40. This is a outgoing interface, WAN interface. Okay, the Vodafone connection. Now what I'll do is I'll go to this interface and I'll enable HSRP. Similar way, I will go to this interface and I'll enable HSRP. That is what I told you. HSRP will be enabled on every networks. Okay, so every network will have its group associated. Now you will see the group coming up and getting associated with this. One more group coming and associated with this. Okay, so let's go to conf t. Let's go to interface E0 1.1, right? That is my first interface, 1.1. Let's define the standby IPs here. So let's say standby. It will ask me for some group number. So as you know, your HSRP version 1 will support in this range. So I'm going to pick 1 and I'm going to give a virtual IP. I'm going to set some virtual IP. It can be any IP which has to be made use of in both the router 19 and router 20. So let's give an IP which is already mentioned over here. So this is for VLAN 1. Okay, see what happened. As soon as you enabled something, as soon as you enabled HSRP, you can see the events happening over here. So let me tell you what exactly happened. So you have your MAC address getting generated. Your MAC address has been generated. Okay, the elections are been happening. So let's see what is the role of this router. So as of now, this has become active. Okay, this has become active and there is no information of the second router yet. It's unknown. This is active. This is on priority 1, and it will have a group name. This is a group name. Okay, so let's go and configure the similar configuration on router 2. So by default, if you see now, from the theoretical point of view, who will be acting as a active? This will start the active role. The reason is because of highest IP address, because the priority is same. I have not changed the priority yet. So your .2 should win the election. So let's see whether that happens or not. I'll go to interface E0 1.0. Okay, it's 1.1, and the standby is 1. IP address is again mentioned here. Okay, so now let's see what has happened. Okay, now they will exchange the hello packets, and they will form the neighborship. See they are going in their HSRP state. Init, speak, and listen. Init, listen, speak, then they declare themselves as standby or active. Okay, so let's see who has taken up the election or who has won the election. This has taken standby, and the second router okay, this has taken active and this has taken standby. Okay, even though this router has a better IP address, the only reason is the preempts are by default not configured. Okay, and there is no way this router can take back the role of active. Okay, so we know this router should have been active, but this is not in this case, because your R19, we configured the HSRP on R19 and it has taken the active role. Okay, and since there is no preempts, it's not going to give back that role. So I will just change, or I'll configure the preempts. Okay, so let's go here and let's say standby 1 preempts. Okay, so let me try preempts here. Okay, so let me give a try with bouncing the port. Okay, so now it has taken the active local state and this will be put up on a standby. Okay.
Hey, if you shut and shut the port, that means preempt didn't work. Is that correct?
Yeah, there might be some bug or something. Normally preempts are to happen without bouncing. Let me check the priority of this. Might be there's something. So this is default, and okay, so basically looks like the preempt command didn't work. So we can see this in the flow. Okay, we can do it now and we can check. So what I'm going to do now is, from our first scenario, I'm going to change the gateway of this device. Okay, Now once HSRP is up, you don't need to point it to the physical interface. Now you need to point this to HSRP IP, the virtual IP, and just close this once. And bring it up. So that's how this Docker work. So you do any changes, you need to once close and once again start this. Okay, let's give a try. 8.8.8. It's working. On which path is it working? That is important. So let's say trace route. Okay, it's taking up 10.2 path. That is nothing but this. The reason is this is acting as a active device. Okay. So when I do a trace route from this, the traffic is flowing over in this direction. The reason is this is active. So I'll shut down this. So once I shut down, let's see what happens. Okay. So I'll go to conft interface e01.1 and let's shut down. Let's ping once again. It's running. So that means it's going somewhere from somewhere, right? So let's see which hop it takes. So it started taking 10.1. That's nothing but this direction. Okay. Now this is a role of HSRP. In your previous scenario, when you were pointing the gateway to the physical interface, and if let's say the box goes down, your traffic is still being sent to that. Okay. There is nothing called redundancy or switch over here. Now as soon as you introduced HSRP concept, you are going to change the gateway to this logical IP address. This IP address is going to create the logical MAC address, which is called as HSRP MAC address, and that is how the MAC address is binded with both the interface. Now it goes to the HSRP MAC address. The MAC address binding will say that this since this is down, I need to send across to this. So let's see the binding on the switch layer. So from the switch layer, if you do see show MAC address, so this is the newly introduced MAC address. Okay. So this MAC address AC01 is learnt on this interface. We also have the actual MAC address of this interface still binded up. Okay. But the traffic is now going over on this. So on the MAC address here, you will see the traffic binded up with this interface. And if you see the next device, that is switch number 2, show MAC address. So you see the MAC address over here is binded with 10, it's binded to this interface, and this has been put down. Okay. So that's how the MAC address of both the HSRP are pointing in this scenario when you just manually brought this down. So let's bring up and also let's see the preempt function. So what is preempt? As soon as I bring up the active router, it must take back the role. Okay. So I go to this interface. I'll make it as no shutdown. Let's see, do we have a reachability still? Yes, we do have. On which direction is it going? Is it on R19 or R20? Okay, so it shows it's still going on R1. Okay, so that means the preempts have not worked. Let me quickly check why the preempts are not taken up. Okay, so this falls under standby. Let me see the configuration. Okay, so preempts are not working because the priorities are not set up. Okay, so I need to set the priority so that the preempt fall back on that. Okay, as of now both are 100, so the preempts is not being functional. So let me go to this interface 1.1 and let's set the priority to like 150, and now the preempt should work, and now it worked. Okay, so for the preempt the priority is a dependency, so you set priority, you will see the preempts start working. Now this becomes active, and this becomes standby. And from the trace route point of view, let's see which path it takes. Okay, so it started taking the R20 path. So now it's taking up this path. Okay, as soon as this router came up with the better priority, the preempts triggered the election and the role was sent back to this, and the traffic is once again here. And let's see from the switch MAC address point of view. So now this switch is pointing the MAC address over on this interface. Okay, and what about the second switch? And on the second switch it's pointing towards 0/1. Now what is that interface? So that interface is this. So your direction is, of course, will take this, because when you are sending a ping or a trace route, your switch is telling go over on this direction. Okay, and that is how your HSRP on backend is technically working. So you just need to know how the packet flow works for a HSRP. Okay, just creating logical IP is not something it's done in the background. In the background, it's also creating a MAC address, and the MAC address is then associating with this logical IP, and that's reason for your flow of the packets. Okay, now as we know, HSRP is not about uh, about the LAN tracking. It can also do the work, it can also do the job across on the WAN side. Okay, so let's say in case this is the path as of now, and for some reason this is down, this switch port is down, so your packet would have been still been sent, right? But that is not going to happen. Okay, because HSRP is capable of tracking this. As soon as it see this is flap, your packet will be sent on this direction. So let's do that. To do that, we need to enable some trackings. Okay, so I'll go to the router 20 first, and from router 20 point of view, let's enable some tracking. So it's called as track. Let's give some tracking number or tracking object. Okay, object number, and from this let's define the interface that I want to track. So I want to track E0/2. Okay, and on what basis do you want to track? On the basis of the line protocol. As of now it will be up and up, so let me show you that. Do IP interface, so it's up and up. Okay, as soon as this interface goes down, that's enough for our HSRP to get triggered up and do the election. Okay, let's define this with the HSRP. We need to map this. Okay, so I'll go back to the interface E01.1, and over here I am going to say standby 1 should track object ID 15. And what is the decrement value? Now this is something which is important and it's little bit on the mathematical side. Okay, so on this router, you know, the default priority is 100, and on this the default priority we set is 50. Okay, so you need to decrement with some number so that the priority becomes lower than this, and that leads to the election. If you just decrement by 10, that's going to be 140. It's again higher than that, so there will be no election. So you need to decrease by at least 60, so the priority of this gets to 90. So that is the whole intention of adding up this. So as soon as the interface goes down, it's going to decrease the priority by so and so number, which will be lesser than this. The preempts, what we configured preempts, will start the election. Okay, and that's how we will see the new active router coming up. So let's say we have decrement by 60. Well, so we did enough thing. Now time to test this. Okay, and how is the packet going? Let's once again check before doing any changes. So it is taking R20. Okay, it's taking R20. That's over here. Now I'll put this under shutdown mode. So I'll go to interface of R20 0/2, and let me put it down as shutdown. Okay, as soon as you put that, your tracking object ID was triggered. It said the interface has gone to down and your election have started here. Okay, it went from active to speak. So from active to speak and speak to standby. Okay, and automatically the second router became active. So let's see the configuration of, or the status of this. So if you see here, let's see show standby brief, and now it's active. And let's see the traffic flow now. So it should point to R19, right? This is a R19 IP. So as soon as the WAN link got flapped, the active box got triggered up. Okay, so this is answer for your question that you were asking, when the WAN circuit goes down, how is your HSRP gonna track, right? So we need to enable the tracking feature. Once the tracking features determine that this interface has gone down, so the HSRP election will re-happen, and then this will be put up. Okay, so let's see from the point of priority. Let's see what happened here. So let's see show standby brief. Okay, so this is a router where I'm running this show standby brief, and you see the priority is 90. Why is it 90? Because I put the tracking rule with decrement of 60. So 150 minus 60 becomes 90, and that's lesser than your R19 router. If you don't take care of this, the election or the re-election will not happen. Okay, fine. So this was about HSRP. So any doubt over here? Hello.
Hello.
Yes, tell me.
Why was it go to PC10? When you were doing trace route, it looks like
Okay.
It only managed to go up to 10.1.
Okay. So that's okay. So let's see if we have reachability. Okay, because we lost the internet connection as of now. So let's see. So on R19, let's see what is the status. Okay, so this is well good enough. And what is the status of E02? And do we have a IP address over there? Okay, so that is not related to HSRP. Might be my own GNS lost connection or something like that, or a routing issue or something. The main intention was to on which router it's leading us.
Okay.
Yeah, because this is a lab environment, so every time some NAT adapter will give some issue or something. But yeah, so that should be something over here. So let me quickly check that there is no issue from my side. Let's ping out from here. Okay, so we have the reachability. So it's all about the internal setup here. Might be some gateway is not set, or okay, now it came up. Now if I run traceroute, so it's going to 10.1 and it went to 32. Now it's going to cloud. Okay, so 32.2 is nothing but my internal adapter. So from there it's trying to reach. So basically traceroute works on different method, and ping works on different method. So you can see the ping is working. Okay, since this is a lab practice, lab environment, so the main thing that I need to focus is on which gateway it's leading me on the case of any outage or a serial link tracking. Okay, fine. So I'll quickly do one more thing, one more configuration that is for two different computers. Okay, and the requirement of or my goal of this lab would be to load share. Okay, that means by default this will be taken up this path because of the highest uh, IP address and also and so. Okay, now let's say how if I configure VLAN 40, but I want and once you configure VLAN 40, that's again going to take this because of that highest IP. But let's make uh, VLAN 40 to consider this path like a load sharing. So for VLAN 40 it will be this, and for VLAN 1 this is going to be the path, and we can set active and standby. Okay, so for VLAN 40 this will be active and this will be standby, and for VLAN 1 point of view this was active and this was standby. So let's do that, and we can wind up then. Okay, so let's go to router 19. So I have configured for 1.1. Now let's configure one more sub interface, that is interface E01.40. I have configured the IP addresses already. So let me show you. So this is what I have done the configuration. Now let's configure the HSRP. So HSRP 40. So 40 is nothing but the object group number. Let's give a IP address, logical IP address, that is now 40.254. Standby 40 preempts. Standby 40 priority 150, because I want manually this router to be the active. By default this will not take up because of the theoretical which we learned. When both are 100 the highest interface will take up. So by default the R20 would have taken, we know that. So I will not waste a lot of time here, so I'll straight away set up priority 150 on M90 on router 19. Now let's go to this interface of R20 or Moscow router 20, and let's set 1.50 standby 40 IP address of this. Let's copy this. Okay, fine. Priority is not required here. Preempts I don't want here. Okay, because preempt to be configured on a active box. So let's check the behavior now. So let's see show standby. I can see two groups. One is group number 1 and group number 40, and for group number 40 this is active, and this is active. Might be okay. Why is it active? Let's see that. Okay, because the priority has gone down. It decremented this. Okay, so let's bring up the interface, which is shut. I'll make it no shut, and let's see if the re-election happens. So the tracking object has detected up line protocol. The re-election triggered the up, and VLAN 1 should be active here. Yes, it is active here, but group 40 is going to be standby on this router because we have set a better priority on the second box. Okay, so the priority by default is 100 here, and over here I have set 150. So by doing this, my both the router will be forwarding the traffic. So my R19 is going to take care of traffic of VLAN 40, and my R20 is going to take the traffic of VLAN 1. Okay, so this way we are load sharing. And let's do the test by changing the config here. Fine, this is set accordingly. So this is the virtual IP, and if I open up this device PC9, let's do a trace route 8.8.8. So it's leading to 40.1. Okay, that's the right device. Let's say if I bring that interface down. Okay, from the switch point of view, let's see the MAC address table. And there is something interesting fact also. Okay, so let's say when I had the MAC address table for automatically generated for VLAN 1, this was the MAC address. Now for 40 VLAN, the MAC address is going to be this one. What is the catch here? What is the format of HSRP MAC address? This is the HSRP MAC address. The last 2 bit here is in a hexadecimal. What is VLAN 1? It's nothing but 1. And what is the hexa value of 1? It's going to be 1. That is why it created a hexa value of 01. But in the case of VLAN 40, what is the value here? What is the decimal value? 40. And what is the hexa value of 40? It's 28. So I can show you that quickly. And that's how your MAC address get created up. Okay. So let's do hexa for decimal 40. So that's nothing but 28. And that's how your MAC address also gets created accordingly. So you have 10 VLANs, you will have 10 MAC address, and the MAC address is what is switching your traffic, right? So as of now, this is switching towards 0.1, which is leading to R19, Moscow R19, because that's an active router. Okay, from PC9, if I do a trace route, it's taking to R19. But yes, for some reason, if this goes down, the interface goes down, let me put it as shut. Now do I have a reachability, or what is the path now? So basically it should take towards Moscow R20, the second router. Okay, so it started taking up to the 40.2. So that's a behavior of MAC. That's a behavior of HSRP. The HSRP states the logical IP addresses, uh, the MAC address behind them, the serial interface tracking. Okay, so what else? Do you have any question here? Something which you wanted to know? And yeah, one more thing which I told you was about the authentication. It's simple thing. You just can introduce the authentication. Okay, so you can set the MD5 or you can set a plain text. So both are supported. But if you're setting up authentication, make sure all the devices have them set up. Okay. Okay, let me show quickly the packet trace, the Wireshark capture. So let me filter out for HSRP. So from HSRP, by default, it's running on version 2. Version 2 have a MAC address, the multicast address on 224.0.0.2. It's IPv4, and let me show you the HSRP MAC address. So this is a MAC address, okay, which where your hello packets are listening. And this is the MAC address that is getting associated with that logical IP. So there are two things. Once you enable HSRP, the neighbors need to go to the rightful device. Okay, what is the role of multicast? So let's say when I have multiple devices, okay, let's say I have HSRP over here, I have HSRP here. Let's say I do not have HSRP here. So multicast will form the neighborship only on this pair, because the multicast MAC address will be listening. Okay, so when a packet, hello packet, is being sent to the router 2, so it will contain some multicast address. So that multicast address will be over listening here. So multicast is nothing but it. See, let me give you this example. So let's say this is a sender. So sender is going to send the multicast address to only group of devices which are running on the same protocol. So they are running on HSRP, then only they are going to form a neighborship. Okay, it's not a broadcast. Broadcast will send to everything. Okay, unicast is one to one. If I know the IP address of this person, I will straight away send a packet. Multicast, I do not know the IP address, but I am sending up to a group of people who are belonging to my protocol, the protocol that I am running. Okay, so for that, your hello packet will contain your multicast IP and all other details. That's what is shown here. The source IP will be shown here. This is your HSRP. This is your multicast address of your version 1. Then we see on a network layer or layer 3, we can see it's a UDP packet. This is a multicast address where the packets are listening. This is a port number, very important. Okay, this is something which is something out of the box, 1985, and little confusing in case to remember. So you need to remember the port number. Okay, the UDP port number for HSRP version 1 is 1985. And what else do we see here? Cisco hot standby router protocol. So we have all the priority value, group value, the virtual IPs. Okay, so this is about the virtual, or this is about the group 1. So Let me see.
Hey, Kavya, why does it say version 0 under HSRP, Cisco HSRP?
Okay, so basically that is a version code. Okay, so that's a version code for your version 1, which only support IPv4. Sometimes this version will be in a hexadecimal, so it looks little weird on a Wireshark and on a live box. They don't will be, won't be a unique thing. Sometimes in a hexa and on a box it will be a decimal notation. So this is for VLAN 40, group 40. Okay. So do we have for VLAN 1? So for VLAN 1, so if you see, there is no tagging happening because by default your native is on VLAN 1. Okay, we have group 1, all those things. Okay, and how do we convert this to version 2? It's pretty simple. You can just change it from, let's do it from here, standby. Okay, interface E1.40, standby 1. Do we have version? Okay, we have version over here, standby version, and we can just make it 2. Okay, so this has gone to init state.
Don't you need the other side as version 2 as
Yeah,
well?
yeah, it is required. And second thing is they are not backward compatibility, so we need to do configuration change. So I was thinking of doing in the next class because we are already very late. Just wanted to wind up. Okay, so we will do this version 2 in the next class, and along with this we will do the VRRP. Again, in the VRRP there are 2 versions. Okay, so is there any doubt before I wind up in this class? So all is fine. This is something which we have already uh, read in CCNA level also, right? Okay, fine guys. So I'll take it as no from everyone. So we are good to wind up. So yeah, do you, okay, there are few chats. By the way, do you guys need class tomorrow or should we meet on Monday? What do you think?
Yeah, let's meet on Monday.
Okay.
Yeah.
Okay, so we have not changed any password for the portal. Okay, so this password was given for the topology to be downloaded or the workbook to be downloaded, but you guys already have the workbook on the portal with the same old password. Okay, so you can ignore that request. Okay, let me show you once again what I'm trying to say. So what I did was I parallelly made one more page dedicated for workbook. So for that I have given you this, but in case you already have the access to the course, then you don't have to worry. Okay, because after all I'm going to put all the workbook, all the videos straight away on that portal itself. So whatever whatever you download, whatever you see over here is the final one. But what I did was I created one more link for the workbook. So might be that is why you got a little confused. Okay, so the only change here is I just took down some interfaces so that I could make the HSRP. But yeah, I can give you this topology once again. Okay, so I'll give you this topology over on the WhatsApp. I'll just paste it. Okay, fine guys. So let's meet up on the Monday. That's what you guys decided, right? Monday, right?
Yes.
Okay, fine. So let's meet up on the Monday with new topics, and we will try to cover up a lot of things in the coming week. Okay, see you and have a nice weekend, everyone.
You too. Thank
Okay,
you.
you as
Okay,
well.
thank
Thank you.
you.
Goodbye.